it's our lecture 3 and we are going to discuss differential equations. The text that we should refer, one is ordinary source that we are going to use so far, that is mathematical methods. And it's easily available in the market. Everyone knows by SM usage. And second one is differential equations with boundary value problems by Dennis Giesel. Differential equations with boundary value problems by D.G. Giesel. And this is by SM Yusuf. So we'll be following these two texts, and if you want to study further, you can refer these two books, and which are easily available in market. So I have already shared with you the teaching plan for today. Maybe you have seen on group or Facebook. So what we are going to discuss today, some of you might know 100% or some of you might know less than that. That's why I have added one or two new topics in that one as well, because everyone knows what is a differential equation, what is the order of a differential equation, what is the degree, and so on.
Yes, sir.
Then we will also discuss today how to solve differential equations by direction fields, also called slope fields, and what are different theorems for the existence and uniqueness of the solution for a differential equation. So we will be discussing one or two new topics, but our beginning discussion would be same as we are doing in differential equations. So we will start with what is the definition of a differential equation, what are the types of differential equation, what is order, what is degree, and when the differential equation is linear, when the differential equation is non-linear, and what is the solution of a differential equation, how many types of solution are there, and so on.
Yes, sir.
And these are like most common questions in any type of common competitive examination. Most common questions and relatively very easy questions.
Yes, sir.
So, since I am discussing only theory, but in every topic of theory we have so many MCQs which can be covered. Like if I say the order of differential equation is this, in an exam you can get any question about the order of a differential equation. They may ask you, okay, what is the order of this differential equation, and so on. They can ask you about, okay, which one of the following equations is linear. So they give you 4 equations, one is linear and 3 equations are non-linear. You can select the non-linear equation.
Yes.
So for this you must know that what is a linear differential equation, what is a non-linear differential equation. So let us begin our discussion without going into depth. So let us define what a differential equation is. So an equation, it is basically an equation involving derivatives, and we know very well what derivatives are, of an unknown function, mostly y, or it is z as well in higher derivatives, with respect to one or more independent variables is called a differential equation. And in short we write it DE. So whenever I write DE, it stands for a differential equation. So it's very simple. We have any equation which involves derivatives of some sort of unknown function with respect to one or more independent variables is called a differential equation. Now this thing is very much important. With respect to one or more, independent variables, and we'll see that why this thing is important. Now let me write some examples of differential equations, and these will be over here for our next discussions. One is dy by dx plus y times cos x equals sin x. Now what is unknown function here? The unknown function is y, and you can see the derivative of y appears there with respect to independent variable x. So we call this a differential equation. And we have like so many other examples. Like the next example is d2y by dx2 plus xy dy by dx raised to power 2 equals 0. You can see in this equation we have the unknown function y, and we have its derivatives with respect to independent variable x. But since this variable is only once, this derivative, but this is twice differentiable with respect to x. Let us see some other examples. I am writing these 4 to 5 examples because on the basis of these examples we will be discussing what is order, what is degree, and so on. So let me completely write these all the equations. So this is 1 plus dy by dx raised to power 2 whole power 3 by 2 equals d2y by dx2, and the next example is x partial z by partial x plus y partial z by partial y equals n times x, and the next example is partial 2u by partial x2 plus partial 2u by partial y2 plus partial 2u by partial z2 equals 0. These all are examples of differential equations. Now you have to just understand one thing, that what is the unknown function here? Y.
Yes, sir.
How many independent variables?
1.
1, that is x. And what is a unknown function?
Y.
How many independent variables?
1.
1, that is x. The unknown function is y, independent variable is x. The unknown function is
Z.
And independent variables are x and y. The unknown function is z,
Yes, sir.
but the independent variables are x and y. Here the unknown function is u. Independent variables are x, y, and z. So keeping in view these all the equations, we can define two things, what we call an ordinary differential equation
For DPT.
In short, we write it ODE. So whenever I write ODE, it means ordinary differential equation.
Yes, sir.
And the next thing is partial differential equation. I write PDE. So what is the difference? I am not writing the whole definition, but just we are going to copy the same definition.
Yes, sir.
So an equation, now I can change equation to a differential equation, because now I am talking the types of differential equation involving derivatives of a unknown function with respect to one independent variable,
Yes, sir.
that is ordinary,
Yes,
with
sir.
respect to more independent variables,
That's PDE.
that is partial differential equation. So simply in this one the characteristic is one independent variable, and here the characteristic is more than one independent variables. Okay, now if you see these equations, you can say that which one of these are ordinary and which one of these are partial.
Yes, sir.
One thing is that independent variable is 1, that is x, independent variable is x, independent variable is x. So these three are ordinary differential equations.
Yes, sir.
Here independent variables are more than one.
More than one.
Y and x 2, x, y, z 3. So these two are partial differential equations. And second thing is, partial differential equation always involves partial derivatives.
Partial.
Always partial
Yes,
derivatives.
sir.
And this involves always ordinary derivatives. And we know very well what do we mean by an ordinary derivative and what do we mean by a partial derivative. We have discussed in multivariate
Yes,
calculus.
sir.
So I can simply say that from equation 1 to 3 are
OD.
ODEs and 4 and 5 are PDEs. So let me write, yes, okay, PDE means partial differential equation. Now our first goal would be to discuss ordinary differential equations, their types, their solution and so on and so forth, and after completion of this we'll move towards partial differential equation. But in partial differential equations we'll need something like we must know what is Laplace transform, we must know what is Fourier series, what is Fourier transform. So maybe we'll discuss those things first, then we'll go to partial differential equation. So it depends. But we can discuss this thing right from now. Okay, so here we knew that what is like ordinary differential equation and what is a partial differential equation. The next thing is, what is the order of a differential equation? I told you that whenever I write DE, it means a differential equation. So I am supposed to discuss what is the order of an ordinary differential equation as well as a partial differential equation.
Yes, sir.
So order is a generic word. So what is order? Yes.
How many time an equation?
Highest order derivative.
Yes, sir.
Highest order
Yes, sir.
derivative. Derivative. And what is degree?
Power of highest derivative.
Power of highest derivative. And I call this some non-standard terminology. I might have written in those teaching plan as well, you might have seen. Because in so many international books, you will not see something like a degree. It is like our notion of defining a degree. Otherwise, in standard books, you will see one thing, that is order, and the second thing is linearity and non-linearity. You don't define what is a degree of a differential equation because it's something that is weird. But we have to understand it because we are appearing in those type of tests which are taken by Pakistani agencies.
Yes, sir.
Okay, so what is the degree? Degree is the
Power
power
of highest
of highest order derivative. Highest order
derivative.
derivative. So we are going to discuss the same equations. So what is the order of first equation? So I am writing here order and I am writing here degree. So we are taking the same equations. The first one, what is the order of this equation?
1.
Because the derivative is only once.
Plus
What is the order of second equation?
2.
You can see this is second order derivative, this is first order derivative. So highest is second.
Yes, sir.
So the order is 2. What is the order of third?
2, sir.
Order is 2 because of this 2.
Yes, sir.
And what is the order of fourth one?
1.
First order differential equation. And what is the order of fifth one? Second order. So these are orders for differential equations.
Yes, sir.
And it is relatively easy to solve first order differential
Yes,
equations
sir.
as compared to second order or third order and so on. What about their degree? What is the degree of this one?
1.
You will see the power of this.
Yes, sir.
So the degree is 1. And if the degree of a differential equation is 1, then we cannot say it is linear or non-linear because this is something non-standard.
Yes, sir.
Linearity and non-linearity depends upon something else.
Yes, sir.
But the thing is that degree is 1 must tell us that it is linear, but it does not tell.
Does not.
The reason is that this is something
Yes, sir.
which is not okay. And what is the degree of this?
1, sir.
You will see the power of the highest order derivative. What is the power?
1, sir.
1. So the degree is 1. What is degree here?
1, sir. Squaring on both sides, yes, sir. Squaring.
The problem is in this equation only.
2 theory.
you are supposed to cancel all the radicals and all the fractional powers.
Fractions, yes.
What is the problem here? The power is 3 by 2.
Yes, sir.
You should cancel 3 by 2.
Yes,
Like
sir.
upon 2 should be cancelled, 3 can be over there.
Three
It's
can
not a
be
problem.
there.
So what you do here basically,
Squaring on
you
both sides.
square both sides.
Squaring on both sides.
Then this 2 gets cancelled and we'll get this thing 1 plus dy by dx raised to power 2 whole cube equals
D is
d2 by dx2 whole square.
yes, sir. 2.
Now this power is not a fraction.
Yes.
So you have to cancel all the fractional powers and all the radicals. Now what is the power of i's derivative? 2.
Two.
So the degree is 2. The degree is 2 in this case. What is degree in fourth case?
1, sir.
What is the power of this one?
1.
Power of this one? First one. And fifth one?
1.
1. Because if you check the power of each and every one, that's 1. So the degree is 1. So this is what we must know when we are going to appear in some sort of test by SPSC or some others. Okay, so the next thing is a bit important and more important than order and degree. And we call that thing when a differential equation is linear and when a differential equation is non-linear. So we are going to define linearity in terms of a differential equation, otherwise we can define linearity in terms of a linear operator as well. But we are not going to that detail because we'll do that when we are studying linear algebra and functional analysis. But right now we are just defining their linearity by the ordinary terminology. So I'm keeping these equations because we'll be using these and I'm removing this side.
So we can say that the main function of degree is tells us the nature of the equation.
Nature of the equation. But mainly the nature is determined by the linearity. Mainly the nature is determined by that thing. Okay, so when a differential equation is linear, so linear differential equation. So when I say linear differential equation, it means I am talking about linear ordinary differential equation as well as linear partial differential equation. So a differential equation is linear if and only if what happens. Number one, so there are 3 conditions that we must keep in our mind
Yes, sir.
when we are saying that a differential equation is linear. What is the first one?
Derivative must be derivative of power 1.
Yes.
Yes, sir. And second one is
Yes. The one thing is that the degree, and degree means
power.
power of dependent variable
Yes, sir.
and its
Derivative
derivatives should be
1.
1. This is one thing. Degree means the power
Yes, sir.
of dependent variable and its derivatives should be 1. So what is the dependent variable?
Y.
Y. What is the power of y?
1.
1. Derivative, what is the power?
1.
1. And derivative, what's the power? 2. So this can be linear, but this is non-linear.
Non-linear.
Why non-linear? Because the power of derivative is 2.
2.
That's why this is non-linear. But we have 3 conditions. We have to see all the conditions.
Yes, sir.
What is the second one?
Product, there is no product.
No products.
Yes, sir. Dependent variable and its derivative.
No products of dependent variable
And its derivative.
and or its derivatives. What do you mean by and or? I have used both words and or. It means dependent variable multiplied by itself, or dependent variable multiplied by derivative, or derivative multiplied by derivative. So there can be any case.
Yes, sir.
There can be any case. So it should not be this case. What is the third case?
No logarithmic or
No
transcendental function in order.
transcendental
Yes, sir.
functions of dependent
Variable.
variable. And what are transcendental functions? We know very well sine.
Sine.
Now this sine or cosine or tangent or log or e, they should not involve dependent variable.
Independent variable. E power y.
If this is involved in that case, then we call that differential equation to be
Non-linear.
nonlinear. So if these three conditions are satisfied, then the differential equation is called linear. And I write one thing else, otherwise
Bernoulli.
non-linear.
Non-linear.
So these are the three conditions that must be satisfied to check that whether differential equation is linear or non-linear. So what about these all the equations? Which one is linear and which one is non-linear?
Only one is linear
One is linear.
and fourth one.
If this is linear, this must satisfy all these three conditions.
Yes, sir.
If it is not satisfying all these three conditions, then it is non-linear.
Yes.
So it satisfies all these three conditions.
One.
No? We are
Satisfied.
talking about one.
Satisfied, sir.
Where is the problem?
It's satisfied.
Because sine or cos functions are
No.
They are an independent variable, sir. Now.
What is the angle of sine or cos?
fixed.
It can be independent variable or whatever. It should not be dependent variable.
Yes, sir.
In this equation, dependent variable is y. If y appears here and y appears here, then it is
It's
non-linear.
non-linear.
In this case, it is linear. So first one is linear.
Yes, sir.
So I am simply writing here L for linear. Second one,
Non-linear, sir. Non-linear.
you can see power of derivative.
Power and product.
And the second condition is also not satisfied.
Product.
Dependent variable is multiplied with the derivative.
Derivative, yes, sir.
So it is
Non-linear.
non-linear. Third,
Also non-linear, sir.
non-linear because when you simplify this, you get some power of
Power
derivative.
of derivative, yes, sir.
So it is non-linear. But I think these two are linear
Linear, sir. Yes, sir.
because this x is multiplied with the derivative.
Yes, sir.
X is independent, not dependent. So it's not the problem. So this is linear and this is also
Also linear.
linear.
So why multiply with the independent there if I'm just talking about this condition?
Fourth.
Fourth one.
Dependent is Z, sir, here.
Dependent is z.
Z here.
Y is not dependent.
Y is not
You
dependent.
have to see that what is dependent variable. Na? Y is not always dependent.
Y is not always dependent. Yes,
In
sir.
this partial differential equation, dependent is z.
Yes, sir. Z only.
Independent are x and y. You have to see the variables as well.
Yes, sir.
If you don't consider the variable, then
Okay.
there might be the problem. So you can see there would be lots of equations which you can classify as linear and non-linear, and relatively it's very easy to solve linear equations.
Yes, sir.
And we always discuss linear equations first. And it will be very much difficult to solve non-linear equations.
Yes.
But there are some methods that help us. Like if the equation is separable,
Separable.
non-linear, we can solve it.
Yes, sir.
If it is homogeneous,
It can be.
non-linear, we can
Yes,
solve
sir.
it. If it is some sort of what other types, Bernoulli,
Bernoulli, yes, sir.
we can solve. Bernoulli is a non-linear equation. We
Non-linear.
can solve it. And there might be some other cases like Clairaut's equation. We can solve those all the equations which are some sort of standard forms, but we can't solve all the non-linear equations. And it is relatively very easy to solve linear equations. Okay, so this thing must be clear. Okay, is this equation linear or non-linear?
No, sir.
No.
No.
The problem is
Dependent variable is in exponential function. No.
this is your transcendental function.
Yes, sir.
Transcendental functions are these.
Yes, sir.
The functions which are not algebraic are called transcendental
Transcendental
functions.
function.
This involves dependent variable,
Yes, sir.
so it's a non-linear differential equation. But it is solvable easily because it is a separable differential
Separable
equation.
equation, yes, sir.
Now you just consider one thing. Your dependent variable is y. If its power is 1, that's linear. If the power of y becomes 2 or 3, or it becomes a negative power, or it becomes a fractional power, these all the cases are for. Non-linear.
Yes, sir.
Now, if you only consider this thing and you don't go for any of these conditions, then you are okay with this. But it will be very much difficult to go for every differential equation. That's why you must know these three conditions.
Three conditions.
Otherwise, the only condition is this. If the power of dependent variable is 1,
Yes,
that's
sir.
linear. If the power of dependent variable is other than 1,
Yes, sir.
that's non-linear. And can you see the power of dependent variable other than 1?
No power, sir.
You can't see, but you
Yes,
can.
Yes,
When you
sir.
expand this,
Third condition.
I'm not going into these conditions, I'm going into that condition.
Okay, sir.
You can expand it, you see.
Series, yes, sir.
So you apply only this condition if you are not okay with these three.
Yes,
So just I'm going to tell you this thing happens. What's the power of y?
2.
Other than 1? So this is non-linear. Okay, you see this thing. Y dy by dx equals sin x. Linear or non-linear?
Non-linear.
Non-linear. Because according to the
Second condition.
Second condition.
Second condition.
But you can reformulate this condition in terms of those. You can write this thing as this.
Yes, sir. Okay.
Because when you differentiate y square, it becomes 2y
2y divided by dx.
dy by dx.
Two to
And that
cancel.
2 cancels in
Cancel
1
with the
upon 2.
half.
So this thing and this thing are same. What is the power of y?
2.
Non-linear.
Yes.
So either keep that condition in your mind, or these three conditions you will get that when the equation is linear and when the equation is non-linear. One other example, that's the final one. And linear or non-linear?
Non-linear by power.
Non-linear.
Yes, sir. Non-linear. Power 2 more than 1.
But this is infinite series. You can see that this thing can be written as e power
D by
dy by. This is exponential series. And when you apply log on both sides, log x and log e gets cancelled. Dy by. Is this linear or non-linear?
linear.
It's linear.
Linear, yes, sir.
Sometimes it happens. But you will not get such a question in your test.
Yes, sir. Okay.
Because this question is a bit typical. Okay, any question or should we go ahead? What is the solution to a differential equation? Solution,
Let's satisfy.
also called integral of a differential equation. So it's simply a function. Let's say y is equal to some phi of x that satisfies a differential equation
Yes, sir.
is called
Solution.
its
Solution.
solution. A function y is equal to phi of x that satisfies a differential equation is called
Standard solution.
its solution. For example, our differential equation is y prime equals y. Then
Integration.
my phi of x is e power x. Is this function a solution to this differential equation or not?
No, sir.
You have y.
No, sir.
What do you do?
Yes,
The
sir.
value of
Yes,
y
sir.
is e
Satisfy.
power x.
It's
Take
satisfied.
the value of y prime means just differentiate it. That would be e power x. Put both values here.
Both values. Yes, sir. Satisfied.
It is same. So this is the solution.
Yes, sir. Solution. It's
So
satisfied.
solution is only a function that satisfies a differential equation, but this function itself must not involve any derivatives. This function should be free of derivatives. So a function can be a function of derivatives as well. Now how many types of solution are there? Our main goal would be to find those solutions, but sometimes you can also check that whether a function is a solution to a differential equation or not. So there are basically two types of solutions. One is called a general solution and another is called a particular solution.
Yes, sir.
So a general solution and then
Particular.
a particular solution. What is general solution? It is basically a family of solutions.
Family of solution.
Family of
Solution.
solutions involving some sort of arbitrary constant. So, for example, I say this is some function y is equal to a e power x. What is a? It's arbitrary constant. It can take any value, let's say from the set of real numbers. Now my differential equation is y prime equals y, the same. Is this function or does this function satisfy this differential equation?
Yes, sir.
Simply you will put the value. What's the value of y? A e power x. You will put it here. A e power x. And you will then differentiate it. Its derivative would be
Same.
a e power x and so a e power x. Now whatever the value of a is, let's say 2, you will get the solution y is equal to 2 e power x. If the value of a is 3,
3.
you will get another solution y is equal to 3 e power x. So basically this is a family of solutions.
Yes, sir.
And such a family of solutions is called
General solution.
general solution. So it's always a family of solutions. It gives you a whole bunch of solutions which satisfy your given differential equation. And if you specify a particular value of a,
Yes, sir.
it means one value for arbitrary constant. And let's say that value we have fixed a equals 2. Then you get 2 e power x.
X.
This is a single solution. We call this a particular solution. So there are always two types of solution. One is called a general solution, which is basically family of solutions.
Yes, sir.
And another one is called particular solution, which is a fixed solution to a fixed given value of arbitrary constant.
Yes, sir.
Now why this thing is so much important and why we are doing so? For example, I have a differential equation y prime equals 2x.
Yes.
It's a differential equation and it can be easily solved. You just integrate on both
Integrate on
sides
both
or by separating variables. Then integral of y prime would be y, integral of 2x is
X square.
x square plus arbitrary constant. So this is solution to this differential equation. But this is a family of solutions because it involves c.
See.
And when you graph this, when the value of c is 0, this becomes something like this.
Yes, sir.
And when the value of c is 1, that this curve passes through 1. And when the value of c is 2, this becomes like this. And when the value of c is minus 1, this passes through minus 1 and minus 2 and so on. So you get a family of solutions
Yes, sir.
for each value of
See.
c. Now, how you can get a particular solution out of a family of solutions? When you are given some extra conditions, we call those initial or boundary conditions.
Initial boundary condition.
So, to get a particular solution, you always need some extra conditions. We
Yes.
call these conditions to be whether initial conditions or boundary conditions.
Boundary
So, what happens that you are given a point x naught y naught from where your solution passes. For example, that x naught y naught point is 1 1.
Yes, sir.
If that is 1 1. So this condition gives you that out of these families you have to select one curve. Which curve? Which passes through this point. Now let's say this is 1 and this is 1 and this is point 1 1.
Yes, sir.
Now you have only
This curve.
a fixed solution and all the solutions are rejected and this particular curve is called particular solution. And how you get that? When you are given some extra conditions, what we call initial conditions or boundary conditions. Okay, so let us discuss what are initial conditions and what are boundary conditions. So, given a differential equation y prime is equal to f of x comma y, and you are given some condition y of x naught equals y naught, and y prime of x naught equals, let's say, y1. Now you can see the value of independent variable is same, that is
Same initial condition.
x naught.
Yes, sir.
And if you have first order differential equation, then you will only have one condition, not two. But if you have second order differential equation, then you might have two conditions. Depends upon the order of differential equation.
Yes, sir.
Now if the condition is only one, that is always initial condition.
Initial condition. Yes, sir.
If the conditions are two, then you have to check that what is the value of independent variable. If the value of independent variable is same,
Same
then it is initial.
initial.
If it is different, then it's a boundary condition.
Boundary condition.
Now what happens that mainly you are given this thing like ds by dt equals f of st, and you are given that s of t naught
T naught.
equals 0. What it means that at time t naught,
T naught.
the distance covered by a body is
0. Yes.
0. And s prime of t naught is 0. S prime means
Velocity.
velocity.
David.
What is the derivative of distance? Is it velocity? Yes.
Velocity.
It means initial velocity of a particle is 0.
Yes, sir.
Why I say initial? Because time is t naught.
T naught.
Sometimes what is given? Initial distance covered by a body is A,
A.
and final distance covered by a body is
B.
B. And these 2 points are different.
Different.
We call these boundary conditions,
Yes, sir.
and we call this
Initial condition.
initial conditions. Initial conditions means the value of independent variable is same,
Yes, sir.
and when the value is different, we call it boundary
Boundary
condition.
condition.
It's very simple. You are given a differential equation, let's say this, and your conditions are y of 0 equals 0,
Yes, sir.
y prime of 0 equals 1, these are initial
Initial
conditions.
condition.
Because value of independent variable is same.
Same.
And when it is y of 0 equals 0, and y of 10 equals 5, these are boundary conditions because
It's different.
the value of independent variable is different. And the problem along with this is called initial value problem, IVP.
Yes.
We'll be using this notation again and again. And this problem along with this differential equation is called
BVP.
boundary value problem. And whenever it is said that given an initial value problem, it means we are given two things. One is a differential equation,
And
second is initial conditions.
Initial condition.
And if we say given a boundary value problem, means given a differential equation along with
Order to
boundary
boundary
conditions.
condition. Yes, sir.
So we are always given these things. Okay, so next thing is how to form differential equations. The formation of differential equations. So the formation of differential equation is simply
Depend upon the number of constant.
eliminating arbitrary constants.
Yes, sir.
I give you a family of circles through the origin with radius r, and I want you to make a differential equation out of this family of circles. Then what is your goal? Eliminate arbitrary constant.
Yes, sir.
What is arbitrary constant over there?
R.
R. Eliminate that. How to eliminate? Differentiate.
Differentiate.
And how many times you can differentiate?
Number of
Depends upon the number of arbitrary constants. How many arbitrary constants are there? One.
One.
What is that? R.
Or
So you will differentiate only
once.
once.
One time.
Differentiate dependent variable with respect to independent variable. It means differentiate y with respect to x. So what I do, I just differentiate both sides with respect to
X.
x. Differentiate with respect to x. This thing is 0.
Yes, sir.
It's a constant. Derivative of x square is
2x plus
2x, 2y,
dy by dx.
dy by dx. This is simply a differential equation.
Yes, sir.
This is a differential equation of family of circles
Yes.
whose center is at origin with radius r.
R.
You can simplify it a little bit, like 2y dy by dx
Is equal to
equals minus 2x. 2 gets cancelled, not minus.
Not minus. Yes, sir.
So dy by dx
X upon y.
minus x upon y.
Y.
So if someone asks that what does this differential equation represent? So it's family of circles.
Family of circle.
And how to know that thing? You have to solve this equation. And these are the questions sometimes in examinations. Okay, you are given a differential equation. They ask you what does this equation represent? A family of circles, or simply they write a circle, a hyperbola, a parabola, or something like that. So what you need to do, you need to solve that differential equation, and solving is very easy. We start from very basic equations like how to solve separable equations and homogeneous and so on and so forth. You can rewrite this one as well, taking y over there, y dy
Yes, sir.
minus x dx, or y dy plus x dx equals 0.
0.
And solving this is very easy because this is a separable equation.
Yes, sir.
Okay, so these are some of the basic discussions on differential equations. Now we'll be taking some examples, some common examples of first order differential equations, and we'll try to solve them. But before moving towards that discussion, we are moving towards some other discussion that when does the solution of a differential equation exist, and there are some other ways to solve differential equations like direction fields and so on.
Yes, sir.
Then we'll come directly towards the basic differential equations. Okay, how to solve differential equations, like how to solve separable, homogeneous, and exact linear differential equations, Bernoulli, and so on. But these discussions are very easy and they won't take much time. For this, our calculus must be good.
Yes, sir.
The calculus of single variable